Base dissociation constant. It is the equilibrium constant for the ionization of a base. Just like any other equilibrium constant, you got to put in your products on the top, reactants on the bottom. It works similarly for the K questions we've been doing previously in our videos. Let's have a look at this one over here. This is going to be our base. It's going to be our acid, because look at this. It is donating a proton. Okay, so if it donates a proton, it's going to be giving it to the NH3. So this is going to be our acid. This is going to be the base because it accepts it. As you can see, the NH3 has now an extra hydrogen over here. This is going to have one less hydrogen, as you can see over here. Now, as you can see, this is a hydroxide. It got released. This is the definition of a base. But the hydroxide doesn't necessarily have to be part of the reactant's formula. Okay, as you can see, none of these have hydroxide, yet a hydroxide gets released. Okay, that's what it means by the OH minus. Concentration is only from the base. Let's have a look at these two questions over here. In order to find the KB, like I said, you have to be putting your products on the top, reactants on the bottom for your equilibrium constant expression. However, we also have to use the ice table just to make sure that we don't lose any values. Okay, so if this goes down and this goes down for x's, well, technically we already know what it is. Okay, we know what the value is. It says it's 6.4% of that value, okay, of 0.1. So if you just multiply them together, you end up getting a value of 6.4 times 10 to the negative 3, okay? Obviously, they're the same because technically they're both x's. You multiply these two together, so you just get that 6.4 times 10 to the negative 3. You just square it, okay? Once you square it, on the bottom, this is going to be our reactant, but technically 0.1 can subtract our x value over here, so you end up getting 0.0936. You divide these two values, you end up getting Kb. What is pKb? pKb is an indicator of basic strength, okay? How do we figure it out? Well, we use this formula, negative log times that Kb. So I'm just going to be putting in my Kb value over here into our negative log formula. I end up getting 3.36. This is your answer. Calculate the pH of the solution. We can obviously tell that this is basic, okay, because we can see it says Kb in the question. Well, we can still find pH by finding the pOH first. Once we find the pOH, we can quickly convert to pH at the very end. So, like always, our Kb, we're going to have the products on the top, reactants on the bottom. Let's create an ice table just in case. Well, this becomes x, this becomes x because these are being produced, these are being gained. So I'm just going to continue to bring it down over here. I'm going to multiply my products on the top, my reactants here on the bottom go there, and then my Kb value, as you can see up here, 1.3 times 10 to the negative 6. I just substitute it into there. I expand this, I get this. I use a subform method, I expand that, I get my quadratic formula here. Once I finish my quadratic formula, I can find my value of x. X ends up here, obviously, to be our hydroxide ion concentration. Well, I can put this into our pOH formula in order to find the pOH, so I end up getting 3.557. Now I can isolate using this formula over here to just isolate from my pH, and I find out that it is 10.44. Please try these two questions on your own. You'll also need the help of this chart over here. This is the answer to the first question. This is the answer to the second question.